This question asks to determine if a reaction is at equilibrium with these concentrations provided. All of these compounds are in a 1 liter container, so it will make our calculations easy. We are given the concentrations of all 3 components, and we substitute them into the equilibrium constant expression, making sure that we square the denominator, and we determine that the reaction quotient Q is less than the equilibrium constant provided, which is 0.018. Therefore, because the reaction quotient is smaller, the reaction needs to proceed forward in order to increase this ratio of product over reactant. In this problem, we are asked to determine the equilibrium constant given the pH and the initial concentration of a weak base, hydroxylamine. Like always, we want to write the chemistry. So here we have a weak base in water producing its conjugate acid and hydroxide. The initial concentration is 0.520, and the change is minus x on the left side of the equation and plus x on the right side. At equilibrium, we have symbolically 0.520 minus x and x on the right side of the equation. Now it might seem like we have 2 unknowns, the x and the kb, which is what we're asked to determine. But we are given the pH, and from the pH we could determine the hydroxide ion concentration. We could subtract the pH from 14 to determine the pOH, and from the pOH we could determine the hydroxide ion concentration, which is our x in this case. Then we could substitute the value for the hydroxide ion concentration into the equilibrium constant expression to determine the Kb. Notice the denominator remains at 0.520 because x is a very small number compared to 0.520.